Hey everyone, welcome back to the channel. We continue looking at the left console today, the the top part. So this is the throttle, which is darkened. We are not building that. So I assume whoever that flies the A-10 will get the Warthog, which is the closest resemblance to the real thing. So we are looking at 4 panels today: SAS, auxiliary lighting, emergency handbrake, and the fuel system. The 4 panels are kind of relatively straightforward and easy, nothing very complicated or challenging compared to later when we look at um, the radios, which are more interesting. So these are quite straightforward. All right. Starting with SAS, I always do the back panel, then the top panel, and I don't do the middle light panel because I don't do backlighting. So back panel, as you see here, this is a top reference. We have toggles. We have a hole to put the lights and the text. We have a toggle here. This one I moved. See, this is the original hole for the part. Um, I am having a bigger cutout to have the whole thing go through, right? And then I moved it to the right. So as shown in my previous many videos, I don't like stick to whatever, even if I'm using somebody else's design. For example, this one is Romeo Kilo's PDF, which we convert, right? Um, here in FreeCAD into um, these panels. So I still take the liberty to make whatever adjustments I see fit. For example, the holes, I'm using smaller ones, 4.3 for this kind of screws, and then I have smaller holes for the 632 screws to hold top panel to the back panel. So wherever necessary, I make changes, even like placement, besides changing the size. So this is how it looks like. Back panel is always 3 mm and top panel is always 6 mm. So the thing is, whatever I'm showing here is my design. Um you cannot just follow this strictly without knowing the size of your switches. Okay, it determines the whole cutouts for all the like for example the toggle. You need to know how big is your toggle so that the diameter fits. It's not too small, it's not too big. And even this one, the parts, or if you're using encoder, all this change. Not only it determines the size of the cutout, what kind of switch you use also determines whether you are securing the switch to the top panel. Therefore, the bottom back panel needs a big cutout for the whole body to go through, or you are securing your switch to the back panel. Therefore, the top panel is just a hole to look at it. So there's a big difference which panel you secure your switch to. All right, it determines how you change the cutout. So like all this I can secure here. I have the lock holes to the toggles. This one I have it big because I'm not securing here, I'm securing to the top panel for the part. So now the top panel, we have the cutout holes to match the back panel and the shape of the panel, and usually text and lines and arrows, whatever, are grouped separately to pad upwards, right, as embossed text. So now at the bottom, as usual, we need a bottom recess for the nuts. Sometimes you have the lock holes. So here at the top, we have top recess for this um, push button, and for the part, and then here we do the lines. Okay, you can use existing lines already drawn in the PDF, or sometimes you want to overwrite. Like this one, you see they are too small, the original ones, and I don't use it, and I make my own lines. Okay, there has been many videos on this, how to draw lines, how to um, merge them together. Okay, so you can review those earlier videos. Then here is the end result of the top panel, top recess, right? And then all the text and all the lines. Okay, so we need two-way toggles, three-way toggle. We need this knob. Many of the A10 knobs can be found. You can either buy them or 3D print. There might be places on Yagi, Thingiverse, Instructables.com, etc. Sometimes you can find the knobs exactly as what you need, okay, or you may be able to buy them from certain websites like PC Flight and EHC or eBay. Um, don't try to buy the original ones. Even for knobs, they can be crazy expensive. Just find some used ones from eBay, or the cheapest way is the free way. If you can find it from Thingiverse and 3D print it, all right. In the past, I started the A10 many years ago, so sometimes I buy the knobs cheap from somewhere, many places, and I used to make a mold and then cast in resin and make many copies of the same thing. So even if I have to buy it, I buy it once. Okay, I don't have to buy 10 of the same thing. So and then we have a part here, and then push button. And this one we have done this LED like for the emergency flight control, for landing gear, and in my F-15E build. I've shown this many times, right? You just have a block, put some text, emboss it, and make a make a container, right, to put the LEDs, and I've shown you wirings. So I'm not going to repeat that again. So one comment about this, we are using Arduinos, and parts using Arduinos, um, they create a lot of noise. Okay, this is analog. Everything else is digital. This is analog signal. It creates a lot of noise, and sometimes when you wire this to Arduino and then have DCS BIOS running, you may see the knobs like jiggling or dancing because of the noise. Okay, um, I've heard that you can also use parts on the Leo Partner boards, right? And they are much more stable running parts on those boards. However, the cost per pin It's like 5 times higher than Arduino. Okay, Arduino you can have like 60, 70 pins because the analog ones can be used for digital ones as well. So 60, 70 pins for like $10 for an Arduino board. And then the Leonard partner boards are like 60, $70 plus shipping plus tax or whatever, and they only do like half the number of pins, so cost per pins is a lot higher. If you are going to use partner, it's very easy to use, right? And you don't need DCS BIOS. um by all means, if for one or two boards is fine, but the A10 requires so many. Even for the mega it requires so many, like 10 or more. So there are few hundred um, switches. So doing the partner way for all the whole A10 or any aircraft, it's going to cost a lot. Okay, so that's why I use the mega is the cheapest. So this is the layout, toggles, buttons, everything. Okay, this is just to show you example of my wiring. um this is analog, so it's A, right? But every time you say A, it doesn't mean it's analog. When I run out of digital pins and I have leftover analog pins, I can use it as digital, which is the case here. The A8 is actually used as a digital pin for the LED lights. Okay, so then this is the DCS BIOS code. This is my actual panel. So you push and then this light up and then all these toggles. Nothing special about this. Okay. So this is left, right. This would be probably momentary on each side. Okay. So next we look at auxiliary lighting. So this is the back panel. So again, you see big cutout means that the part is going through and mounted on the top and just going through the back panel here. So we have a toggle here, we have two parts, another toggle. This will be a three-way toggle. Okay, and then two buttons here. So this is how it looks like. So when it's something simple like this, there's no top recess, bottom recess. Okay, usually for the back panel. Now for the top panel, we do the shape first and the cutout for all the shaft holes, right? And then separately we will do text and lines and arrows. Okay, now the lines, and this is the top recess, bottom recess, and all the lock holes. So lock holes, bottom recess. So this is how it looks like, top panel. So when you see red lines, it means that they were from the PDF that are not used, right? I just use this part. I don't want to emboss this because when I put the whole knob, I want it to sit flush. I don't want, if you emboss this, the knob will be sitting on the embossed lines. So I cut it out. I just emboss the outer edge. So again, some toggles, another knob and part and push buttons. So this knob is black. um if you cannot find it gray, get it black and then spray paint it gray. That's it, right? If you are doing backlighting, then obviously you need to either make a mold, cast this in clear acrylic, or 3D print this in clear PLA, then pray, then paint, and then put this thing, stuff like that. I have never bothered with backlighting. I find it easier to like when everything is done, shine some green LEDs on the whole console. Backlighting is too much work, so it depends what you want. So, okay, so two parts, okay, A2, A3, everything else is digital, toggles, push buttons. So again, this is very easy. And the code, all right. So now, as usual, DCS BIOS, whenever there is a part, the default code given is potentiometer. Then for whatever reason, if you don't want to use parts and encoder, you have to switch to the advanced view in order to find the code for encoder. So this is my panel. So okay, the brake handle. Um, Besides the PDFs, sometimes we get the STL file for certain knobs from Romeo Kilo as well. So I think under miscellaneous or something, I found this. So this is the brake handle, right? I separately made this, okay, emboss the text and then just stick it here. All right, and then you have a metal tube, and then I secure it vertically to prevent this from spinning. Just have a screw from the bottom. If you put it here, this is in the way, so I tighten the screw from the bottom up and put a nut here. So if a pipe here, and then you put your um, push pull switch at the back. Okay. Obviously, if your tube is hollow, you need to fill it with something like hot glue or some other thing that is solid. Um, okay, so back panel. So there are two layers of this. This is the top panel, and then you have a bottom panel. This is the bottom panel, depending on how yours is made. Okay, so this is 90 degrees, but this is not 90, this is like further up 95, and then the big hole is to let the whole toggle go through. Okay, it's secured on the small seat adjustment panel that we'll see in a minute. And then this big hole is to let this toggle whole body go through. All right, so this is a simple build, but it took a couple of tests to get it right. So this is the top panel, and the top panel, these two screws secure it to the back panel, but this one is to opening, and the special screw is to secure the back panel to the console. All right, so nothing really special about this, but it's very customized. If you are using Link's DK, um, he's he was selling the console and the Jesus rail, the kind of stuff. Then um, this is the probable dimension that you want to use. Okay, and this is the seat adjustment panel. I'm not having any knob on it. I just use a flat toggle and momentary up and down to adjust the seat. All right. So mine is closer to this very popular picture that shows the whole A10 cockpit. So it's just a flat panel, and this is like switching. This is pull vertically up. So this is the original, like this is the real A10, and this is the traditional way. This is almost like a pyramid, right? and then you have this. But mine is like flat down. Okay, on here the adjustment, and this is vertically up, so it's different. But this is very simple. Okay, so now the fuel system, the last panel we are looking at, back panel again, big openings for all the body. These are the 4 push-pull toggle switches. All right, and then a lot of toggles. So, and here you have the opening for the lever. So you have a part here, a push button, and all the rest are all toggles. Okay, as usual, the text and whatever lines have to be done separately from the cutout. This is just the cutout. So having the PDF helps a lot because you just convert them, okay, and either pocket or pad. So now the bottom recess, and this knob, I think you can find it on Thingiverse. And then you either have a piece of wood or print it, 3D print this. All right, this hole is for this, for the screw, and then you put 2 micro switches here, and then this will, like, you know, flip up and down. And this, I have a L bracket to hold this piece to the panel here. Okay, this is an old design made of wood, so I 3D printed, so it's, the picture shows how it was done. So we have 2 knobs, toggles, part, push button, 4 push buttons, 2 micro switches, quite a lot of stuff here. This panel is quite big. And here are all the numbers, just one analog, right? Everything else is digital. So this is the final product, how it looks like. So most of the knobs are gray in color. And here is the DCS BIOS code. All right, so basically these 4 panels are straightforward. Some of them have a lot of switches, so it's just tedious, but it's not complex or confusing. In the next video, when we look at the radios, VHF, UHF, those panels, besides the switches that are simple, the most challenging thing is the frequency display, right? Using 7-segment displays, that can be challenging in 2 ways. One is the wiring. How do you wire them? You can use them straight out of the tube, but in some cases you need special wiring. And then also the code. You can copy and paste from people out there from the forums or Discord, but if you make a mistake or you want to make some changes, if you don't understand the code, then you are stuck. So I will do a very detailed tutorial on 7 segments, which will help you not just to do the VHF and UHF, but even others like Tekken and ILS. Obviously, all these are for the A-10C, but the understanding of the wiring and the code for 7 segments can be applied to other aircrafts, right? F-18, F-18 doesn't have 7 segments. Maybe F-16 or whatever other aircrafts that use 7 segments, um, this can come in handy. All right. At the beginning, it seems very complex, but 7 segments look kind of cool. Um, yeah, and we'll see that it is not rocket science after all. So thank you guys for watching, and I will see you in the next one.